All right, everyone, welcome back. Get ready for another deep dive, like we did last year with Chemistry Nerd.
Yeah,
Well, get this. There's a sequel,
there is. Chemistry Nerd Book 2.
Chemistry Nerd Book 2.
Yep.
It's
Yeah.
out now, and oh boy,
It's amazing.
this one takes us even deeper
Oh, yeah.
into the world of chemistry.
If Chemistry Nerd was like the foundation, this
Yeah.
one is like
Well,
launching us into space.
all right, so no more like basic periodic table stuff.
Yeah, no.
This is like next level.
Yeah, much more advanced stuff.
So what really stood out to you in this one?
Well, one of the things that I thought was really fascinating was the whole concept of astrochemistry.
Astrochemistry.
So it's basically where astronomy and chemistry meet.
Okay.
And we're looking at the molecules and reactions that are happening in space.
Wait, so you're telling me that there's chemistry going on, like out there in the vacuum of space?
Yes.
I mean, I remember from the first book that molecules are like, constantly moving and bumping into each other to react.
Yeah. Right.
But I kind of always imagine that happening, in a beaker or something,
Yeah.
not in a nebula.
That's what makes it so cool, though, right?
Wait,
That even in the cold and the near vacuum of space, you have these complex molecules that are forming.
like what kind of complex molecules are we talking?
Water, carbon monoxide, even organic molecules like glycine.
Glycine, like the amino acid.
Yeah.
The building block of protein.
Exactly.
In space.
And space.
It's crazy.
It's amazing. And the book talks about how, these discoveries in the Orion Nebula, which is this, massive star-forming region,
Yeah.
really kind of raises the question of, are the building blocks of life more common in the universe than we think?
Whoa. Okay, my brain is like officially tingling now.
It's pretty wild.
Okay, so we went from the vastness of space.
Yeah.
But where else does Chemistry Nerd Book 2 take us?
Well, let's bring it back down to Earth a little bit,
Okay.
but with a green twist.
Okay.
So green chemistry is a big focus in the book.
I'm all for, saving the planet and stuff.
Yeah.
But I have to admit, when I hear green chemistry, like, the first thing I think of is not, super exciting.
Yeah, it doesn't necessarily sound like the most thrilling topic.
Right. So break it down for me. What makes green chemistry so special?
Well, I think the book does a really good job of laying out these 12 principles of green chemistry.
Okay.
And it's those principles that are really driving this kind of chemical revolution.
Okay.
So, for example, catalysis.
Yeah.
It's a core principle in green chemistry, and it's all about using catalysts to speed up reactions.
Okay.
Make them more efficient, reduce waste.
So we're basically finding clever ways to do chemistry, but like without all the bad side effects
Yes.
and the environmental headaches.
Exactly.
Wow.
And the book gives some cool examples like bioplastics
Right.
made from things like cornstarch to replace, those petroleum-based plastics
Yeah.
that are kind of causing problems for the planet.
Yeah. Okay, so green chemistry. I'm starting to see the appeal.
Yeah, it's pretty cool.
It's like we're using, our knowledge of chemistry to actually solve some of these big problems.
Absolutely.
But Chemistry Nerd Book 2, I have a feeling doesn't stop there.
No, it doesn't.
What other, chemical rabbit holes does it take us down?
Oh, so many. Nanochemistry, molecular machines, the chemistry of extreme environments.
All right, you officially have my attention. But let's take a quick break, and then we'll come back and unpack some of those mind-blowing topics.
Sounds good.
All right, we are back, and my brain is like buzzing after that last segment. We went from the cosmic scale with astrochemistry down to the planet-saving power of green chemistry.
Right.
So what is up next in our Chemistry Nerd Book 2 adventure?
Well, let's shrink ourselves down to the nanoscale and dive into the world of molecular machines.
Molecular machines.
Molecular machines.
That sounds like something straight out of science fiction.
It kind of is.
Are we talking like tiny robots building stuff like atom by atom?
Not quite that advanced, but essentially, yeah, molecular machines are these molecules that are designed to perform specific tasks at the nanoscale.
Okay.
So the book talks about how scientists are engineering these molecules to move, rotate, even act as switches,
Whoa.
all at a size that's thousands of times smaller than a human hair.
But how do they even build these things? I mean, it's not like they have these tiny little tools to manipulate these molecules.
Right. Well, that's where the awesomeness of supramolecular chemistry comes in.
Okay.
So the book explains how they use these principles of non-covalent interactions.
Like what?
like hydrogen bonding and van der Waals
All
forces,
right.
to basically design molecules that self-assemble into these intricate structures.
So it's like they're creating molecular Lego blocks that just snap together to make these tiny machines.
Exactly.
That's amazing. But what's the point? Like, what can they actually do with these molecular machines?
The potential applications are huge, and Chemistry Nerd Book 2 does a really good job of exploring that.
Like,
So imagine like a molecular machine that's designed to deliver a drug directly to a cancer cell,
yeah.
minimizing side effects, maximizing effectiveness.
Well,
Or how about self-healing materials,
oh, wow.
where molecular machines are actually repairing damage at the molecular level?
That's incredible. Okay, I am officially on board the molecular machine hype train.
Yeah, they're pretty cool.
But you mentioned earlier, like, extreme environments.
Yes.
What kind of, like, chemical craziness happens when we, like, you know, crank up the heat or the pressure or go to the other extreme, like super cold temperatures?
So let's dive into the depths of the ocean,
Okay.
where you have these hydrothermal vents
Okay.
that are spewing out this superheated water that's
Mm.
rich in chemicals. It's
Right.
one of the most extreme environments on Earth, and
Yeah.
yet life thrives there.
Life in that boiling chemical soup. I thought most living things need sunlight to survive.
Yeah, that's what's so cool about it. They don't rely on photosynthesis.
Oh, wow.
They use chemosynthesis.
Chemosynthesis.
So these specialized bacteria use the chemicals from the vents as their energy source,
So it's like these bacteria are having a chemical feast at the bottom of the ocean.
pretty much.
That is wild. But what does that have to do with chemistry?
Well, it's all about the reactions, right? The extreme conditions near these vents drive reactions that just wouldn't happen in normal environments.
Okay.
It's an example of how life has adapted to take advantage of the unique chemistry of its surrounding.
So it's like chemistry is happening everywhere, even in these, like,
Yeah,
crazy places where we wouldn't expect it.
exactly.
I'm starting to see a pattern here with Chemistry Nerd Book 2.
Yeah,
It's like they're taking all these concepts that seem abstract
right.
and showing how they actually play out in the real world,
Yeah.
whether it's in the depths of the ocean or even within our own bodies.
Exactly. And it doesn't shy away from the truly bizarre.
Oh, what do you mean?
For example, the book dives into this whole world of high-pressure chemistry,
Okay.
where materials behave in ways that we just wouldn't expect.
High pressure chemistry. Okay, now you've got my attention.
Right.
What happens if you take something familiar like water and you put it under immense pressure?
Well, under enough pressure, water can actually turn into ice, even at room temperature.
Wait, so ice, that's hot.
It's called supersonic ice,
Superionic ice.
and it's thought to exist deep inside planets like Neptune and Uranus.
That's crazy.
It is pretty wild.
But that's what I love about this book so far.
Yeah.
It's constantly challenging, like, my assumptions about how the world works at, like, a chemical level.
And it doesn't stop at high pressures.
Oh, no.
It ventures into the world of low-temperature chemistry,
Okay.
where reactions slow down and quantum effects start to become really important.
Great.
It's where you see things like superconductivity and superfluidity.
Okay. My head is officially spinning.
It's a lot to take in.
I got high-pressure chemistry, making weird ice, and low-temperature chemistry, making things act all super strange.
Right.
What else does Chemistry Nerd Book 2 have in store for us?
Yeah. Well, before we get completely lost in the extremes, let's
Yeah.
maybe take a step back and look at some of the amazing discoveries
Okay.
and potential applications that we've already talked about.
Yeah.
Sometimes it's good to just pause and appreciate the ingenuity and creativity of the chemistry that's happening all around us.
Okay, so my brain is like still buzzing from all this mind-bending chemistry we've been talking about in Chemistry Nerd Book 2.
Yeah, it's pretty amazing stuff.
So what other, like, gems did you find in this chemical treasure trove?
Well, we were just talking about high-pressure chemistry.
Yeah.
Remember supersonic ice?
Yeah, the hot ice. I can't get that image out of my head.
It's pretty wild, right? Well, it turns out that they've actually been able to create it in the lab.
What?
Yeah, using these super powerful lasers to generate those extreme pressures.
So they're like recreating the inside of planets in a lab?
Pretty much. It's amazing how far the technology has come.
That's incredible. But what about, like, practical applications of high-pressure chemistry? Is there anything beyond just, like, blowing our minds?
Absolutely. The book mentions this material called a carbon nanothread,
Okay.
which is made under immense pressure. It's like this ultra-thin carbon structure that's super strong and flexible,
Stronger than diamond.
potentially even stronger than diamond.
Wow.
So imagine the applications, building lightweight materials for spacecraft or
Oh.
electronics that are both durable and efficient.
Okay, that's one for the Did You Know file, for sure.
It's pretty impressive.
But we also, like, ventured into that chilly realm of low-temperature chemistry.
Yeah.
Did anything in that frosty frontier stand out to you?
Well, remember we talked about the plasticky super low temperatures.
Really?
Yeah. Chemistry Nerdbook 2 highlights how they're using these enzymes to try to revolutionize recycling.
How so?
Imagine being able to break down those stubborn plastics into their building blocks at low temperatures using less energy,
Yeah.
creating a truly circular economy for plastics.
So it's like the solution was there all along. We just needed to explore the extremes a little bit.
Exactly. And that's kind of the message that I got from the whole book.
What do you mean?
It's not just about memorizing, facts and figures.
Right.
It's about embracing the wonder and potential of chemistry.
I couldn't agree more. This book has been like a wild ride, pushing the boundaries of what I thought I knew about chemistry.
It's really opened my eyes, too.
So if you want to embark on your own chemical adventure, Chemistry Nerdbook 2 is definitely the way to go.
It's an amazing book.
Yeah, mind-blowing facts, cutting-edge research, and it even has a glossary to help you with all the technical terms.
Yeah, it's perfect for anyone who's interested in chemistry.
So who knows? Maybe you'll be inspired to make your own chemical discovery someday.
That would be amazing.
Thanks for joining us on this deep dive into Chemistry Nerdbook 2.
It's been a pleasure.
Until next time, keep exploring, keep questioning, and keep that chemistry spark alive.